Hi, I'm Jox. Today we're going to be doing and working on the horizontal partitioning for Postgres database. And I'm going to be using the Docker container for this session. And actually I have some script so that I could run and spin up our Docker container for the Postgres and the pgadmin. So I could just copy the Postgres from here and I can spin up. So I have a Docker run, -d is to run on the daemon process, -p is for the port mapping, the localhost port or the host machine, and then the container port, and we are mapping. And we also need the environmental variable for the Postgres. So the Postgres username would be Postgres itself if you don't change, and for the password I'm just going to put it root. And we have another environmental variable, it's pz data, and the path should be exactly this. And other path doesn't work, so this is for the Postgres. And just for the simplicity, I also have attached my volume, my localhost volume, and the container volume. This is really not necessary, but for the sake of simplicity, I'm just putting it. And then I name this container or the image as a Postgres, and I'm gonna spin up or create one of the network, and the network name is Postgres network. And I'm gonna be calling this image Postgres from the Docker Hub, since I don't have it locally. So it's gonna be pulling from the Docker Hub. So probably take some time, but hopefully it's gonna be faster. And in the meanwhile, I can also run the pgadmin. Pgadmin's for the dashboard. I'm just gonna copy this. I'm gonna clear out my screen and gonna paste this. So the same thing, docker run -d daemon and the port mapping. So for my localhost, I'm gonna be using 5050, and 80 is a default port in a container. That's HTTP, and the environmental variable pgadmin default email, and you can have any email or any username. And another environmental variable is a delphi123 is my password. You could have any other password, so I'm just putting this, but you can put anything. And we're going to be pulling these images from the Docker Hub, but I think I'll need a network as well, so I'm just going to copy the network as a Postgres network. So I could just paste it here. And same, I don't have it locally, and it's going to pull from the Docker Hub. So probably take some time, and once done, we can see the running container. Okay, there you go. So I have two running container. One is the pgadmin, another is the Postgres. So actually we could even go to our browser to see the pgadmin, to view our database from the pgadmin. So this is my computer, and it's a 5050 is the port. So probably it's loading. In the meanwhile, we could even check the logs for the pgadmin. It says running, so here we have. So I had a username as development.ai and dlvi. Okay. There you go. So if I didn't see any server here, you can add new server. You can name it anything, app, and then you could have the same IP. In your case, it could be a local host, but I'm simply using one of the server from EC2, and maintenance dv, that's a Postgres, and the password would be the Postgres. Sorry, the username is the Postgres, and the password is the root. So I'm gonna save it, and it's giving me some sort of error, unable to connect to the server, the password or the username. I think it's the Postgres. I can just go and verify. It's a root, R-O-O-T, and the username should be the Postgres, simply the Postgres. I'm gonna try again. If it doesn't work, I can just go inside the container to run that. Sorry. Okay. Still no. It doesn't really matter. I'm just gonna close this for now, but I'll go to the Docker container and then run our program. This is the Postgres. I can go inside this container and then bash it. Okay, I'm inside that. The username is Postgres. There you go, it's working here, but I don't know why it didn't work on the pgadmin. And we can see the list of tables here. and this is the table that I had it, and others are by default. So I can create a new table here. So simply we could do create database testdb. There's some typo, database database. Okay, I have a table and I can use this database. It's not use, it's C. Alright, we are connected to the testdb. So I can see the list of tables. At the beginning there is no table, so I can just create one table that is a customer, that has a customer ID and the CID. ID is simply the auto increment, and CID would be the values that we're going to be inputting. So let's create that. Create table customer with ID, and it's auto increment, so it's a series. Serial, serial, not null. And we need to have a customer ID, and this also not null, such that we're going to create this as a partition table. So we have to use a partition and by range on CID, customer ID. Oops, I forgot to put the data type, so it's going to be integer. There you have, we have a table. So now I can check the table. So I have a table and the type is a partition table. So this is a little different here. We set the partition table, but if you create just a normal table, you will see the table only. But this is the partitionable table, so it's called partition table. So now to have a partitions, we can create like a multiple partitions. But before that, let's try to insert some record. Maybe not now. Maybe we can create a basic table here, like a partition table. So let's say our customer ID ranges from 1 to 100 or 0 to 99, so that we split this big table, several millions of record, into 4 partition table. So let's create those partition table first. Create table. I can say CID. Okay, I forgot to check the details of our table. Customer. Okay, so right now it says no partition, it's a 0. Okay, I also wanted to create the index for this table. Create CID index on our table customer, customer, with index on the CID. Create, oh sorry, index CID IDX on customer tables. Okay, we created the index on that table, so that I can go to the details. So now I have an indexes CID using a B tree on the CID. So on this field we have a indexing, so that's great. So let's create a partitions for that table. Create table. So we need 4 tables, so let's say first table, no, rather the easier would be 0 to 25 on this table. Create a table this, so this have to be an index from the table customer. So we could do like customer, including indexes, INDE. There you have. So we need to create a 4 table. So simply 25 to 50, and then from 50 to 75, and 75 to 100. There you have. So now if you go to the details, no, just for this. So we have a table customer, which is the partition table, and other 4 table. These are the partitions for this customer. So you have a table, and this one is just a partition table. So you saw the difference right here. So once we created those table, as well as we need to create the index for these table as well. So let's create an index. Create create index. I'll just copy this. Index on this table for CID. Okay, same goes for this table as well. And lastly, one more table to have an index. So okay, there we have. So now we have a 4 partisans. So now we need to attach those table onto the table customer. So let's do that with some sort of a protocol or some sort of a rule from 0 to 25 on this, and so forth, 25 to 50 on this table. Okay, so now we need to attach that table. So to attach, we first need to alter our existing table. Alter table customer, and then we need to attach partisan. First I'm gonna attach this table, and I define the rules for values from 0 to 25. Okay, so that's been attached. So if I just go to the table details, if I check the customer, so there you have, we have a partisan 0 to 25 on this table. So the customer table have these two field as well as this partisan. So as well as we need to attach some other from 25 to 50 onto this table, and so forth. From, we just need to repeat that, 50 to 75 on 50 to 75 table, and lastly to 100. So now if you check the details, there you have. So we have two fields or the two columns, type integer, and we have an index on CID, and we have a partisans for this and this. For tables are the partisans, and we have a rules from 0 to 25 and so forth. Now okay, we did that. Now for now I don't think we have any record on our table, so just see, select count all from customer, there's nothing, 0 records. So we can insert some of the record, some as in 10 million records or 1 billion records or 100 million records. To make it faster, I'll just do 10 million. So insert into our table called customer, but we don't need to insert ID, we just need the CID, just this one. I'm just gonna copy paste it. So, and the value should range from 0 to 99. So, but we're gonna be using the auto increment, that's a series, and we call that as a series. So insert into customer from this table, select all from generate series, right? GNERATE series. Okay, and how many records? From how many are there? Okay, this is going to be 10 million. Oh, okay, but our values should range from 0 to 99. So there will be 10 million records for the value 0 to 99. So I'm going to use a random values, and to make it integer I will just multiply by 100, but then I want it to have a floor value so that it doesn't go to 100. So it's going to be integer. Let's see. So it's taking some time to insert the record on this table, and CID is indexed. Looks like it's taking really long for the 10 million records, just with the 2 column. Let's see how long does it take. Hope it's not hanging. Okay, there you have. It took quite a long time. So 10 million records been inserted. So we can just check how many records are there now. We just did the select count from this, and also you could check with the explain analyze. there you go, trying to explain how long does it take and what protocol or the algorithm does it use, and it's taking really long. Oh, you see here, so it's actually using the worker, using a thread, 2 workers, and see we had like a partition table from 0 to 25 and 25 to 50, 50 to 75 and 75 to 100, and it has to go through all those 4 tables, and then it's doing all the operation, and finally it's aggregating. So because we are doing the select count on all the records, so if we do something simpler like select all from customer where CID equals 89. Okay, this is pretty much faster because when we give this value like 89 for this customer, and in this case it's just doing the index only scan, which is way faster, and since 89 would be in between 75 and 100, and it just looks into this partition table, only on this table. So see, we were able to skip all those other 4 tables and just went to this table, did the index only scanning, and gave us the result in 158 millisecond, which is way faster than without having a partition. By default, like it's 4 times faster because it doesn't have to go through other table, just have to go through this table, so it's way more faster. And also you could see the values in the partition table. Select max CID from, so if we look into this table, the max would be 24, and if you look for the min, it's just going to be 0. And also if you look into the other table, it's starting from 25 and ends with 49. Yeah, same goes for the other table as well, but I'm just going to skip it for now. And the way it does, explain, analyze, select max from this. If you do that, it does the index only scanning and it gives us the result in way faster over here. So you know, using this would be equivalent to using just reading from one table. So if we do exactly the same thing, select count all from this, so I have to put something in between 25 and 40, so I put this exactly the same, 156 millisecond. So instead of checking all the 100 million records, it's just checking this many records, only this much of records, which is way faster. Sorry, not that, I have to remove this. Only 2.5 million records. So out of 10 million records, you just have to check 2.5 million records, and it's much more faster, way faster than going through all the 10 million records. So if you check other table, how many records we have, so almost 2.5. We already did that, so we can go through 50 to this 2.5 and 2.4. Yeah, so in total we would have 10 million records, and now we already understood it's way faster to have partition than to not to have. When there are many hundred millions of records or the billions of records, having a partition saves our time. So yeah, this is all for today. Hope this would be useful for you guys. Thank you.